Hey there, ready for a deep dive? We're going to be talking all about LLM engineering today, and we've got some really cool excerpts from the LLM Engineers Handbook to dig into.
This will be a good one.
Forewords, chapters, we've got it all. So
All the good stuff.
think of this as your crash course in, what it really takes to build these powerful systems. We're talking about the nitty-gritty, the behind-the-scenes stuff.
Absolutely. And we'll be drawing insights from the book's hands-on example, the LLM Twin Project, to show you how these concepts actually come to life, not just the theory.
Perfect. Okay, so the book jumps right in and makes a bold claim. AI is becoming the default for how we build technology.
It's a big statement.
It is. And the foreword by ZenML CTO really drives this home, emphasizing that LLMs will be absolutely essential in the future, not just a nice to have.
Yeah, and I think it's easy to dismiss that as hype, but when you look at the speed at which LLMs have evolved, especially in recent years, it's pretty remarkable.
It is. But there's often a misconception, I think, that LLM engineering is all about the algorithms, the really complex, fancy math stuff.
Right. Yeah, I can see how people would think that.
Like if you don't have a PhD, you can't even get started.
Yeah, but the book really emphasizes a much broader perspective. Strong software engineering skills are just as crucial as a deep understanding of, the AI itself.
So it's kind of like you can have the most powerful engine in the world, but if you don't have a well-designed car built around it, that engine's not going anywhere.
Exactly. That's where the FTI architecture comes in. Think of it like a factory, Raw data comes in, gets transformed into usable features, then it's used to train the model. Finally, we use an inference pipeline to actually use the model, put it into practice.
Okay, that factory analogy is kind of clicking for me. So FTI, it stands for Feature Training Inference. But why is that structure so important? Why is that the go-to approach?
Well, it's all about modularity. Each of those pipelines, feature, training, inference, they can be developed and scaled totally independently.
Oh, okay.
So in a real-world project, that's huge because it allows different teams to work on different parts of the system without stepping on each other's toes.
So it's kind of like having specialized teams in your factory,
Right.
The assembly line, quality control, shipping, all working together seamlessly.
Precisely. And this modularity becomes even more crucial when you consider the complexity of real-world LLM applications like the one explored in the book, the LLM Twin.
Yeah, that's where things start to get really cool.
It does.
Okay, so remind us just quickly, what exactly is the LLM Twin?
Okay. Imagine having a digital version of yourself that can, write just like you. That's the LLM Twin.
Spooky.
It is a bit spooky, but
A little creepy.
very cool.
Yeah.
So it gathers all your online data, like articles you've written, code, social media posts, whatever you've got out there, and it builds a model that can capture your unique style and voice.
It is fascinating, but it's a little creepy too, right?
Mm.
Is my digital twin just going to start posting on Twitter without me knowing?
Yeah. That's a conversation for another time. Perhaps.
Wow.
Perhaps one about AI ethics, but
Yeah, exactly.
But in this case, the LLM Twin is it's just a really brilliant way for the authors to walk us through the whole process.
A good example.
Yeah, from data collection to all the way to deployment. And that starts with gathering the raw material.
Which sounds honestly way less glamorous than training a fancy AI model, right?
Yeah.
What are some of the challenges involved in that initial data collection stage?
Well, for the LLM Twin, you're pulling data from all sorts of places, Medium, LinkedIn, GitHub, and, each platform has its own quirks.
Yeah, they do.
So the book digs into web scraping techniques, like using simple methods for some sites, and then tools like Selenium for sites that, try to block scrapers.
It sounds like you need a whole toolkit just to get the data in the first place.
You really do. And it's not just about getting the data. It's about doing it, gracefully, respecting rate limits, handling errors, making sure your scraper can adapt as websites change, all those little things.
Yeah, those little things
They
that
add up.
trip people up.
They do.
Okay, so it's kind of like being a digital detective. You need the right tools and techniques to gather evidence without tripping any alarms.
Exactly. And then once you've got all that raw data, it's time to refine it.
So we're taking that messy pile of data and turning it into something an LLM can actually learn from.
Right.
What's that process look like?
So it's about cleaning and transforming the data. And the techniques really depend on the type of data you're working with. For text, you might break it down into smaller chunks or create embeddings, for semantic search using these cool tools like vector databases. The book even gets into how to use ZenML to organize all of this in a logical way.
So it's kind of like taking a rough diamond and cutting it into a brilliant gem.
Yeah,
Right?
I like that.
You're revealing the true value hidden within the data.
I like that analogy.
But this is where it gets even more interesting.
Oh, yeah.
Before we even get to training the LLM, we need to talk about Retrieval-Augmented Generation.
I heard it.
RAG.
ARG. Okay, I'm intrigued.
So think of RAG as giving your LLM access to an external knowledge base. It's a way to combine the vast knowledge that's already stored in the LLM with specific info retrieved from, outside sources.
So if the LLM is like a brilliant student, RAG is like giving them access to a massive library.
Perfect analogy.
Right. They can still use their own knowledge, but they can pull in specific facts and figures when they need them.
Exactly. Imagine you're asking your LLM a question that requires specific details, but it might not have been trained on those details. With Argo, you can first search for relevant documents in a database, then feed that info to the LLM along with the original question.
So the LLM gets kind of the best of both worlds, right?
It does.
Its own internal knowledge, and then this curated set of relevant information.
Yeah.
I'm starting to see why this is a big deal.
Yeah, it's powerful stuff.
But I'm guessing the book doesn't stop at, just basic RAG. Does it delve into some more advanced techniques as well?
Oh, absolutely. For example, it covers query expansion, where you're using another LLM to generate multiple ways to phrase your search query. So instead of just one way to ask the question, you get 5 or 10 different ways to ask it, which can really broaden your search results.
So it's like brainstorming with an AI, right?
Exactly. It's like
Yeah.
having a brainstorming session with an AI to figure out the best way to even phrase your question.
Exactly. And then there's self-querying, which is where the LLM actually analyzes the user's question to extract additional info that can help refine the search.
Yeah, it gets really meta.
Yeah, whoa.
So, for example, if the question includes the user's name, well, now you can use that to personalize the search results.
It's like the LLM is becoming a detective, right?
It is.
Piecing together clues from the question itself to find the most relevant information. Is there anything else, any other RA tricks up their sleeve?
Oh, there's one more. Re-ranking. After retrieving a set of documents, you can use another LLM to re-rank them based on how well they actually match the intent, the true intent of the question.
So we're going beyond just simple keyword matching, right?
We are. It's about understanding the deeper meaning, like the context of those search results. It's like having an AI librarian who understands your research needs, even if you're not using the exact right keywords.
Okay, that's awesome.
It highlights how LLMs can be used for so much more than just generating text. They can improve search, retrieval, all sorts of things.
Okay, I'm sold on RAG. What about training the LLM? We hear all this buzz about fine-tuning. I'm assuming the book covers that pretty extensively.
It does, but it goes way beyond the basics.
Okay, good.
It explores supervised fine-tuning, or SFT, in depth.
And just so we're clear, SFT is where we give the LLM a bunch of instructions and answers, right? Like, here's what we want you to do. Here's some examples.
Yeah.
Exactly. But one of the challenges the book highlights is the need for really high-quality instruction data sets. You need clear, well-formatted instructions and accurate answers. The book even talks about different formats for these data sets, like Alpaca for single-turn instructions and Shared GPT for multi-turn conversations.
So it's not just about feeding the LLM any old data. It's about carefully crafting the instructions, the examples, so the model learns the right way to behave.
Right. You got to teach it good habits.
Yeah. Now, I bet they delve into some specific techniques too, right? Like LoRA and QLoRA.
Oh, absolutely.
I've heard those thrown around.
Those are really exciting because they allow you to fine-tune massive LLMs even if you don't have, a supercomputer at your disposal.
Right.
They focus on updating only a small subset of the model's parameters, so you don't need as much computing power.
That's great for people who are just getting started, right?
Huge. It opens up fine-tuning to a much wider audience.
Yeah. But tell me, what happens when we want to go beyond those basic instructions and tasks? How do we get the LLM to sound more human, more, nuanced?
I was just going to ask that. How do we get that personality in there?
That's where preference alignment comes in, and this is where it gets really interesting.
Okay, preference alignment. You said things were about to get interesting. Don't leave me hanging.
So SFT, it's great for those basic tasks, teaching the LLM what to do, but it doesn't quite capture that human touch, that nuance we're looking for. Preference alignment takes it a step further. Imagine providing your LLM with multiple responses to the same prompt and then ranking them from best to worst.
So you're basically giving the LLM feedback on its writing style,
Right.
right? Like, this is good, this is not so good.
Exactly. And the LLM learns what humans actually prefer,
Okay.
making its output less, robotic, more aligned with our expectations.
Mhm.
The book uses direct preference optimization, or DPO, as its
Ah,
example.
DPO.
Mhm.
Got it. So through DPO, are we essentially like shaping the LLM's personality? Is that a fair way to put it?
You could say that. We're guiding it to produce output that sounds more human, more like how we would communicate.
Wow. Okay, so we've gathered our data, we've prepped it, trained our LLM, we've even given it a bit of personality. What's next? Time to unleash this thing on the world, right?
Almost. But deploying an LLM, that's a whole other challenge.
Yeah.
These models are computationally intensive. They need like a lot of careful optimization to run efficiently.
Yeah, you can't just like stick it on an old laptop and hope for the best.
No, not really.
And that's where that INFTI comes in, right?
Yeah.
Inference.
hmm
That's about actually using the trained model, right? Putting it to work. What does the book have to say about optimizing that stage?
Well, one of the first things it covers is KV cache.
KV, as in like key value.
Right.
What does that have to do with LLMs?
So remember how LLMs process text sequentially?
Yeah.
Each new word or token depends on what came before.
Right.
Without a KV cache, the model could end up redoing the same work over and over again as it's generating each new token.
So a KV cache is kind of like a memory bank for the LLM, right? It lets it store and reuse previous calculations so it doesn't have to start from scratch every time.
Exactly. It makes things much more efficient.
That's clever. Anything else that helps these things run a little smoother?
Oh, there's speculative decoding.
Okay, speculative decoding.
This one uses a smaller, faster draft model to predict upcoming tokens in a sequence.
A draft model. Is
Yeah.
that like having a rough draft of the text before the main model gets involved?
Exactly. So the main model only needs to check and refine the draft rather than generating everything from scratch.
Honestly, that sounds kind of risky. What if the draft model gets things wrong?
There's always that chance, but the main model is there to correct any errors. And the speed improvements can be, significant, like 2 to 4 times faster.
So it's like a high-speed writing collaboration,
It is.
with one model laying down a rough draft and the other one coming in to polish it up.
Yeah.
That's a neat way to think about it.
Yeah, it's a good analogy.
But, LLMs, they could be real memory hogs. Yeah, they can.
Does the book address that at all? Like how to deal with those memory demands?
It does. It dives into memory-efficient attention techniques.
Okay.
You see, the attention mechanism, that's the heart of a transformer, but it could be very memory-intensive.
Right, because the attention mechanism is what allows the LLM to focus on different parts of the input as it's generating the output. Kind of like how we focus on certain words or phrases when we read.
Right.
But as the input text gets longer, those traditional attention mechanisms can really struggle.
Exactly. And the book mentions some techniques like flash attention 2 and page attention that are designed to be much more memory efficient.
So they help make sure those resource-hungry attention mechanisms don't, crash the party, right?
You got it. It's all about making these models run smoothly on realistic hardware.
Makes sense. Okay, so let's say we've got our model. It's optimized. It's running efficiently. How do we actually get this thing out into the world? How do we deploy it? That's a great question. So one of the first decisions you'll face is whether to go with a monolith or a microservice architecture.
The classic debate.
Right.
Monolith, where everything's bundled together in one big package, versus microservices, where you're breaking the system down into smaller, independent parts.
Exactly. Monoliths are simpler to get started with, but they can get messy as the project grows.
Yeah.
Microservices are more flexible, more scalable, but they require careful coordination between all those different parts.
So what does the LLM Twin Project go for?
Well, they opt for kind of a hybrid approach.
Okay.
So they use a REST API for, the business logic things like handling user requests, authentication, that kind of stuff.
Right.
But the LLM itself is deployed as a separate microservice.
Makes sense. That way the LLM, which probably needs specialized hardware like GPUs, it doesn't bog down the rest of the system.
Exactly.
But how do they make the deployment process, smooth and efficient? Because manually setting up servers and configuring environments, that sounds like a nightmare.
It can be. And the book showcases a great solution, Hugging Face DLCs.
DLCs, like downloadable content for video games.
Well, not quite in the same way, but the idea is similar. DLC here stands for Deep Learning Containers. They're pre-built Docker containers, specifically designed for deploying LLMs.
So it's like getting a pre-assembled Lego set instead of having to sort through a giant pile of bricks. That's much more appealing.
Exactly. And these DLCs, they include everything you need, the right operating system, libraries, even a powerful inference engine called TGI, which stands for Text Generation Inference. It's all right there.
It's like having a fully equipped workshop delivered to your doorstep.
It is.
You just bring your LLM.
Yeah, and you're ready to build.
And these DLCs make it super easy to deploy to platforms like AWS SageMaker, right?
Absolutely.
That name keeps popping up. SageMaker.
It's a very popular cloud-based machine learning platform, and it's really well suited for deploying LLMs. It handles a lot of the heavy lifting for you.
All right, so we've got our LLM all packaged up in its fancy DLC. We've deployed it to SageMaker. Are we done yet? Can we celebrate?
Almost. But there's one more crucial piece that the book covers: auto-scaling.
Auto-scaling. Does that have anything to do with those tiny cars you buy at tourist track?
No. Auto-scaling is about handling the unpredictability of real-world traffic. Imagine your LLM suddenly goes viral.
Oh, okay.
You're hit with, like, a massive surge in requests
Our system would buckle, right?
without auto-scaling.
It probably would.
Yeah.
So the book details how to set up auto-scaling for SageMaker endpoints so that your system can automatically add more resources when demand increases.
Right, so you're only paying for what you need.
Yeah.
And when traffic dies down, it scales back down.
Exactly.
So it's like having an elastic server room that expands and contracts based on the workload.
I like that analogy.
That's really smart. Okay, so we've built our LLM, we've optimized it, deployed it, made it scalable. Can we finally pop the champagne?
Well, there's one more critical aspect the book emphasizes. MLOps, as in like machine learning operations. So it's like DevOps, but specifically for machine learning.
That's a good way to think about it. You see, the book doesn't just stop at building the model.
Right.
It highlights the importance of continuous integration and deployment, versioning everything, your code, your data, your model, and setting up robust monitoring.
So it's not just about building a cool LLM, it's about building it in a way that's like sustainable.
Right.
And it can evolve.
Yeah.
Making sure that the whole system runs smoothly and reliably in, a real-world setting.
Precisely. And there's one more fascinating element of MLOps that the book dives into: prompt monitoring.
Prompt monitoring. That sounds really meta. What's there to monitor about the prompts we give the LLM?
It might seem strange, but it's incredibly important. LLMs are powerful, but they can also be unpredictable.
Right.
A poorly crafted prompt could lead to unexpected or even harmful results. And that's not what we want.
So prompt monitoring is like a safety net, making sure the LM doesn't veer off course and do something we didn't intend.
You could say that. It's about proactively identifying potential problems before they turn into serious issues.
Wow, that's a level of detail I never would have considered.
Yeah, it's really important.
It shows just how much thought goes into building and deploying these complex systems.
It really does.
We're not just playing around here.
No. This is serious stuff.
Okay, I think our listeners could use a moment to, absorb everything we've covered so far.
Yeah, it's a lot.
When we come back, we'll try to tie it all together and explore some of the broader implications of this deep dive. All right, welcome back to the deep dive. Hopefully everyone's brains are still functioning after all that.
There's still a lot to cover.
Because we're about to tie everything together and explore what it all means for you, for anyone out there who's thinking about diving into this world of LLMs.
Yeah, we started by examining that bold claim that AI is like the new standard for building technology, and we really went deep into the practical skills, the considerations that go into LLM engineering.
We've covered it all, right?
Yeah.
Data collection, FTI architecture, RAG, all the fine-tuning techniques, deployment, even MLOps.
The whole shebang.
It's a lot to take in, but it's all connected.
Yes.
So let's step back for a second. Look at the big picture. What are the key takeaways for someone who's serious about becoming an LLM engineer?
Well, one of the most important things to remember is that, LLM engineering isn't just about understanding those models themselves.
Right.
It's about having a strong foundation in software engineering principles, best practices.
Right. It's like the difference between admiring a beautiful painting and actually understanding the techniques that the artist used to create it.
Exactly.
So you can appreciate it on one level, but to really understand
To really get it.
you need to go deeper.
And to build truly impactful LLM applications, you need to understand that whole ecosystem.
Right.
Data pipelines, deployment, monitoring tools, all of it.
It's like building a house.
Right.
You need more than just an architect's blueprint. You need skilled carpenters, electricians, plumbers, and they all need to work together to make that vision a reality.
That's a great analogy.
And that's where that FTI architecture comes in.
Yeah.
It's like the blueprint.
Yeah, it gives us a framework for thinking about the whole development process in a modular, scalable way.
Manageable chunks.
Yeah. Each stage, from feature engineering to training to inference, it can be developed and optimized independently, which is essential for real-world projects.
And then the LLM Twin Project
Yeah.
that the book uses as its running example. That's such a great way to see how this all comes together
Absolutely.
in practice.
Yeah, it's hands-on.
It shows you how to tackle a real-world challenge, start to finish, highlighting those practical considerations at every step.
It really demystifies the process.
And the book doesn't shy away from the complexities either.
No, it doesn't.
It dives into those advanced techniques, query expansion, self-querying, all that stuff.
Yeah, and those can significantly enhance the performance of your LLM applications.
Right.
Make them more efficient, more accurate, more human-like in their interactions.
That's like learning those secret tricks of the trade from a master craftsman.
Exactly. And then there's MLOps, which, building the LLM, that's just the first step. You have to think about maintaining it, updating it, monitoring its performance, and making sure it runs reliably in a dynamic environment.
Right. It's about building a sustainable system.
Absolutely.
One that can evolve and adapt.
Yeah.
And a key part of that is prompt monitoring, which, it sounds kind of minor,
Right.
but it's becoming so crucial as these LLMs get more powerful.
Yeah, it's about being proactive.
We need to be vigilant about the prompts that our systems receive. Analyze them for potential issues, set up safeguards to prevent those unintended consequences.
Couldn't have said it better myself.
So it's like having a quality control team, right? Constantly inspecting the raw materials that are coming into our LLM factory, making sure everything is up to standard.
A good analogy. We've got to stay on top of things.
Okay, we've covered a lot of ground.
We have.
Is there anything else you think our listeners should be thinking about as they kind of embark on this journey into LLM engineering? Anything that goes, beyond the specific tools and techniques that we've been discussing?
That's a good question. I think one of the most important things to consider is the evolving relationship between humans and LLMs. We've talked about how LLMs can augment our capabilities, make us more efficient, more creative, but we also need to think deeply about the potential impact of these technologies on our society, our culture, even our sense of self.
Right. It's like we're standing at the edge of a new frontier.
We are.
And the lines between human and machine are getting blurrier and blurrier.
And it's crucial that we, navigate this new terrain with a sense of wonder, but also with a healthy dose of caution.
Yeah, it's important.
We need to be mindful of the ethical implications and make sure we're using these technologies to create a better future.
To make the world a better place, not just a more efficient place.
Exactly.
Well said. Well, I think it's time to wrap up this deep dive into the fascinating world of LLM engineering. Hopefully you're feeling as energized and inspired as I am.
It's been a pleasure.
And to all our listeners out there, keep exploring, keep learning, and keep pushing the boundaries of what's possible. Until next time.